This is the lab that determines G on an incline. This is the lab setup. First, I need a motion sensor, which are connected to my iPad. If you can see, there is the graph. So as soon as the lab starts, when I start to click collect, and it will show me the graph for the motion. And the track down here, which we need a card, put it on there. And the track is about 120 centimeter. And also some chemistry textbook to help us to create that incline plane. First, I need a measurement of the thickness of the book. So each chemistry book is about 4.1 centimeter. As we said, the book thickness, which is the height of the book, is 4.1 centimeter. But just be aware, the label here is meter, so you might need to convert 4.1 centimeter into meter. Which also here, incline plane, the length, we said it's about 120 centimeter. But you have to convert that into meter. As you're looking at this diagram, so the next thing you have to calculate is sine theta. And as the diagram shows, this is the angle theta that I have. X is the length of the incline plane, which we said it's about 120 centimeter. And then this, the height of the book will change, depends on the number of the book I stack up. So as we said again, sine theta is equal opposite over hypotenuse. Here is the demonstration. First, I need to put the motion cart on the ramp and make sure it can go back and forth freely. Then I'll move it to close to 1 centimeter mark. Then hit collect and then release the cart. As soon as the cart hit the end of the ramp, I click stop. Here is what I'm seeing from my iPad. And this is a graph which is given. On the top, it's a position versus time graph. On the bottom, it's a velocity versus time graph. What I need to do is looking into velocity versus time graph. If you remind yourself again, velocity versus time, delta V divided by delta T, which that's acceleration. That's one of the data points that we need for this lab. To be more clear, I need to zoom in to see what really happened in the graph. So this is what I'm seeing after I zoom in. As you can tell, from 0 to 0.5 seconds, the line was pretty horizontal. That's the moment that I was holding the cart on the top of the ramp. Then from 0.5 seconds all the way till about 2.7 seconds, the motion cart velocity is increasing. And then at the end on the top, that's the moment when the motion cart hit the bottom of the ramp. What I need to do is consider that we just talked about velocity versus time. The slope of that, it's your acceleration. Using this app will actually help us to find out the linear line for that, which is the slope for this portion. Now I'm going to show you how to find it. Apply curve fit. And apply. Now if you can see from the screen, y equal mx plus b. That's our linear graph. M is equal 0.3253. As we just get the slope for that linear line, which is 0.3253. And that was velocity versus time graph, which the slope of that graph is the acceleration. As you're looking into the data table, so I will put down 0.3253. I am going to keep repeating that process for another 2 times to fill it in here and here. After I have that number, I can get the average acceleration. So that was just a quick demonstration. The next few things I need to do is increasing the number of a book. First trial, we use 1 book. Now I'm going to stack it up into 2, then 3, then 4, then 5. So here is all the data that I got from my trial, which you can use to finish this lab. A few things to think about. The length of the incline plane, because we're using the same incline plane, which means that should not change. But the height of the book, because we change the number of the books, that means the height might change. So you need to do some calculation. From the rest of the page, please show all your calculation there. And with all the acceleration from trial 1, trial 2, trial 3, you should be able to get a number for average acceleration. After the data table being filled, now we're looking to the next page. Number 2, there is already helping you out. You do need to use a graphing paper to graph the average acceleration versus sine theta, which your average acceleration will be your y-axis. Your x-axis will be your sine theta. Number 3, after you plot those 5 points in there, you do need to figure out your best fit line. After that line being done, you do also need to find out what is the linear equation for that best fit line. After the equation was solved, you should have something y equal mx plus b. So typically, you need to use the points on that best fit line to solve for m and solve for b, that's the knowledge from your Algebra 2. Number 4, now you have to figure out when sine 90 degree equal to 1, which means if your sine theta is 1, what is the value of your y from your best fit line?